Hi, in this video I'm going to show you how to find the molecular formula given the percent composition. This one is a little more involved because you're going to have to first find the empirical formula and then find the molecular formula. So when we find the empirical formula using our percents, we have to assume a number. The easiest number to assume is 100. That way if I have 100 grams, 40% of 100 grams is 40 grams. So I'm going to rewrite that. And it's 40.0 grams of carbon. Here we got 6.7 grams of hydrogen. And here we've got 53.5 grams of oxygen. And when finding the empirical formula, I have to find the lowest whole number mole ratio, keyword mole. So I'm going to convert all of these grams to moles. Put what I want on top, 1 mole for every so many grams of carbon. I have to look at my periodic table, and we've got carbon, which is 12. Flipping back, I'm just going to set all these guys up right here. 1 mole of oxygen, here's hydrogen, here's carbon. So looking for hydrogen, we have, well, you can't see it right here, it's 1, and then we're talking about oxygen, which is over here 16. Flipping back, should really extend that. Alright, so we got 1 gram and 16 grams for oxygen. Alright, so now we're going to use our calculator, which you should always bring to chemistry class because you'll need it. Alright, I'm going to type in 40 grams and divide it by 12. It gives me 3.33. It's really crunched. I'm just going to rewrite it right here. I've got 3.33, so 3 sig figs because I start with 3 numbers. And that's moles of carbon. 6.7 times 1 divided by 1. It's not too bad. That's 6.7 moles of hydrogen. 53.5, that'll need my calculator, divided by 16, 3.34 moles of oxygen. Alright, once I have all my moles, in order to find my lowest whole number mole ratio, I need to divide all of my answers by my lowest answer. In this case, it looks like 3.33 is my lowest answer, so I'm going to divide each of these by 3.33. So that gives me 1 carbon. 6.7 divided 3.33 gives me around 2. And, well, this is going to give me around 1. So I have a 1 to 2 to 1 ratio. So as I write my empirical formula, that is C H2O, 1 carbon, 2 hydrogens, and 1 oxygen. Alright, now that I have my empirical formula, I can then begin to find my molecular formula. And I'm going to use the formula of N equals molecular mass divided by empirical mass. And N is going to be my multiplier of all my subscripts. I'm going to multiply each of these subscripts by N. So it kind of be written as CN H2N ON. Multiply all my subscripts by N. Alright, my molecular mass, it's always going to be given to me. Here it's 60.0. That's my molecular mass, 60.0 grams. I'm then going to divide it by my empirical mass, which I have right here, my empirical formula, so I got to find the molar mass of this. And I look at the atomic mass in the periodic table and I find that carbon is 12, hydrogen is 1, but there's 2 of them, and oxygen is 16. 16 plus 2 plus 12, let's add that up, 30. So my empirical mass is 30. Take my molecular mass divided by empirical mass, I get 2. So I'm going to multiply all my subscripts by 2. That's going to get me C2 H4O2. And that is how you find the molecular formula given the percent composition.